If polynomial equity is clear, then let's move on to the next topic, which is the remainder theorem. So this is extremely important in additional mathematics because I can tell you for sure that at least one question, which is basically question 1 or question 2, is going to be based on the remainder theorem and the factor theorem. So it's very essential that you know this. So yeah, let's get into it. So when a polynomial p of x is divided by x minus k until a remainder r is obtained, then r equals p of k. So that's our statement. So x minus k is the divisor. The dividend is p of x, and the r is the remainder. So if you put k into the function or the polynomial, you'll get the remainder. This may seem confusing, but let's prove it. So when we divide a long division or like a polynomial by a certain divisor, which is x minus k in this case, this is what we get, right? P of x equals q of x, which is the quotient, multiplied by k minus x plus r. So now it states that r equals p of k, right? So if we put the value of k into the equation, we get p of k equals q of k into k minus k. It doesn't matter what value of quotient we get, but we just need to notice that this becomes 0. So when this becomes 0, this whole term becomes 0 because anything into a 0 is a 0. So we are left with the remainder. So that's how we prove this, and that's how we know that this statement is indeed true. So now let's just look at this also. So if p of x equals x minus k into q of x plus r, we get p of k equals to r. So if p of x is divided by x minus k, it leaves a remainder of r. So the takeaway from this slide would be that if a polynomial is divided by x minus k, but k is a constant, then the remainder would be p of k. So if that's clear, let's move on to the questions. So the divisor is x minus 1, which is in the form x minus k, implies that k equals 1. So in order to find the remainder, we need to find f of 1. Let this be f of x equals this. So r would be f of 1. So let's substitute the value of 1 into the polynomial given. So it would be 1 cubed plus 2 into 1 squared minus 7 into 1 plus 8. We get 1 plus 2 minus 7 plus 8. We get, when we add this and this, so this would be 3 minus 7 plus 8. 3 plus 8 would be 11 minus 7 equals 4. So the remainder would be 4. Okay, so let us actually do the long division to ensure that it is the statement that we have gotten, this statement is actually true. So let's do this. You know the drill. Divisor, I will do it in a different color. So the divisor on one end, the symbol with the polynomial inside, minus 7x plus 8, close it, and now we write x squared here. So this would be x cubed minus x squared. Let's subtract this. This would give us 3x squared. Let's bring down the 7x. So this is going to be plus 3x. So 3x squared minus 3x. Let's subtract this. We get minus 4x, bring down the 8. This would be minus 4. So minus 4x plus 4. When we subtract this, we get 4. So the remainder is indeed 4. And that's what we got here also. Moving on. So let's look at this question. So when this polynomial is divided by x minus 2, the remainder is 7. So let's write down the information we know. So let's define the function f of x as x cubed minus 2x plus a. So here we're supposed to find the value of a. So this is our question. And the divisor would be x minus 2 and remainder is 7. So we know that if the divisor is x minus k, then f of k equals r. So let's write x minus 2 comma f of 2 would equal r, implies that f of 2 equals 7. So let's substitute this. Okay, so we get the value of a equals 3. So let's use long division to actually prove that the remainder is indeed 7 by substituting the value of a into the equation. So the divisor on the left hand side and the polynomial inside. So over here it would be x squared. So x cubed minus 2x squared. Let's subtract this. It's going to be 2x squared. Bring down the 2x minus 2x, so it's going to be plus 2x. So 2x squared minus 4x. On subtracting this, we get 2x, bring down the 3, it's going to be plus 2. So 2x minus 4, when we subtract this, we get 7, which is the remainder. So we are indeed right. Moving on, let's move on to this question. Let's choose a nice color, this blue. So yeah, so here you can see that this is not in the form of x minus k. It's rather in the form of ax minus b. So it looks confusing, that's true. But then let's just break this down from scratch and see what we'll actually have to do. So we know that p of x equals q of x into the divisor. Divisor, I'm not going to write anything, I'm just going to write b of x plus r. So in this case, let's substitute the divisor as ax minus b. So q of x into ax minus b plus r. So we have to make this term 0. So we can write q of x into a minus b equals to 0. So this the quotient, we're not 100% sure that it's going to be 0. In most cases, it's never going to be 0. So we are supposed to make this 0. So ax minus b equals 0. So when upon rearranging, we get ax equals b and x equals b by a. So we get P of B by A equals Q of X into A into B by A minus B plus R. This would give us Q of X. This gets cancelled, so B minus B plus R. So we get Q of X into 0 plus R, which is R. So we do get the remainder. So when it's in the form of AX minus B, you have to use the formula P of B by A. So yeah. So now let's solve this question. So let's read the question. So we have to find the remainder when the polynomial 4x squared minus 10x plus 1 is divided by 2x minus 1. Okay, so here the divisor is 2x minus 1. We equate this to 0, we get x equals 1 by 2. So we have to write P of x equals 4x squared minus 10x plus 1. We write P of 1 by 2 equals 4 into 1 divided by 2 whole squared minus 10 into 1 divided by 2 plus 1. We get 4 into 1 by 4 minus 5 plus 1. This is 1 minus 5 plus 1. So it's 2 minus 5, which is minus 3. So the remainder is minus 3. Now let's do long division to find the remainder. Okay, so the divisor on one end, the polynomial within, which is 4x squared minus 10x plus 1. Then we write the quotient here, so it's going to be 2x because 2x into 2x gives us 4x squared. So 4x squared minus 2x, and then so minus 10 plus 2 would be minus 8x. Bring down the 1, we write minus 4, so minus 8x plus 4. Upon subtraction, we get minus 3, which was also our previous answer. So now let's solve this lengthy problem. So let's define P of x as x cubed plus 2x squared plus ax plus b. So it's given that when the polynomial is divided by x minus 1, the remainder is 4. So it implies that P of 1 equals 4. So therefore 1 cubed plus 2 into 1 squared plus a plus b equals 4. So we get 1 plus 2 plus a plus b equals 4. So a plus b equals 1. So let's write this in terms of b. So b would be 1 minus a. Let's name this as equation 1. The second condition is that when the polynomial is divided by x plus 2, the remainder is 16. So that means p of minus 2 equals 16. Let's substitute the values in. Negative 2a plus 1 minus a because of this, get 16, so minus 3a equals 15 implies that a equals negative 5 and b equals 1 minus a, so equals 1 minus of minus 5, that is 6. Therefore a equals minus 5 and b equals 6. So this is our final answer. So now let's actually divide the polynomial by the two divisors to make sure that we got the right values of a and b. So let's do that. Okay, so let's first divide by x minus 1 and put this in. A was minus 5, b was plus 6, and let's find this now. So it will be x squared, so which is indeed the thing that they had given. So we got the right value of a and b. Okay, so let's divide by x plus 2 to also confirm that the remainder is 16. So let's do that. This is just to confirm again. So let's do that. This is just simple long division. So x squared, so x cubed plus 2x squared. So this whole thing cancels out. We are left with minus 5x plus 6. So minus 5 would be minus 5x minus 10. When we subtract this, we get 16. So that was what was given. So this further confirms that the value of a and b that we got was true.